In example 18, the function of x is equals to the sine of x all the way from negative 360 degrees. The value of x is between negative 360 and positive 360 degrees. The part A, sketch the graph of y is equals to gx. And as you know, the graph of y is equals to gx is simply the graph of the sine curve. When x is 0, we will talk about when x is positive 180 degrees. We'll talk about when x is positive 360, again negative 180 degrees, and negative 360 degrees. The maximum value of sine x is 1, and the minimum value is obviously negative 1. We know that sine 0 is 0, sine 90 is 1, sine 180 is 0, and sine 270 is negative 1, and sine 360 is 0. We also know that the sine of negative 90 is simply negative 1, the sine of negative 180 is 0, the sine of negative 270 is 1, and the sine of negative 360 is 0. You may confirm that. We have done this before, so we don't think we need to do it again. We just have to remember what we know. And that is the graph of y is equals to sine x, or rather the function of x. Having done that, this is part A. There is part B, whereby we are supposed to construct, or rather to sketch, the graph of y is equals to modulus of the function of x. As you can see, the modulus is upon the whole function, and therefore this way we are not supposed to give the values of y as negative numbers, because even when they are supposed to be negative numbers, at that point they are moduled to be positive numbers. What did we say? This one, all negative y values are reflected along x-axis, and this gives us something like this. The same thing, minus 180 minus 360, 180 degrees, 360 degrees, and this is the value of x. We are very comfortable from negative 360 to negative 180 because all those values of y are positive. But from negative 180 to 0, the values are we are very comfortable from negative 360 to negative 180 degrees, moving to the right, because these values of y, as you can see, are already positive. But between negative 180 to 0, you can see the values of y are negative, and these are the ones now we need to reflect along the x-axis. So this part, of course, gets to that part. That's a reflection. Again, from 0 to 180, comfortably, the values of y are positive, so they remain very positive. But between 180 and 360, they were negative, and we need to reflect them along the x-axis. So at the end of the day, you realize that the values of y which were negative, particularly this part and this part, they are now reflected along the x-axis, and they are simply positive. Now, it is part C that we must look at closely, because we are expected to sketch the graph of y is equals to the modulus of x itself. The modulus of, or rather the modulus of x itself. It is the x which is moduled. It's the x which is moduled. The x itself is moduled. And this gives just what we have seen in the previous video, that x is not supposed to be negative. So we only consider the value of x when they are positive. So at this particular point, it is only x itself that is moduled. It is not the value of y. So the value of y is free to be positive or negative regardless of the value of x. So we would wish now to consider, the original value. When x is positive, we had a graph that looked like this. And this is 180 and this is 360. We have no quarrel because x is already positive on the right hand side. But whether x is negative or positive, it does not affect the value of y, simply because it is x that was negative that is moduled to give the value of y, which was reflected when x was positive. So whether x is positive or negative, the value of y does not really matter. So as you can see, when x was 180, you will obviously see, you will now look at it. When x was 180, the value of y was 0. So when x is negative 180, the value of y is still supposed to be 0. But look at it this way. When x was 90 degrees, the value of y is supposed to be 1. When x is negative 90 degrees, because now x is negative and it is going to be moduled to be positive 90, that means it's going to reflect the value of y when x was itself 90. So the value of y remains 1. And again, this gives you something of this nature. So that is this part reflected along the y-axis. And again, if you would want to talk about this particular point, and this is 270 degrees. When x was 270 degrees, the value of y you can see is negative 1. When x is now supposed to be, let's say, negative 270 degrees, which when this one is moduled, it becomes 270, and that means it will continue to reflect y being negative 1. So whether x is positive 270 or negative 270, the value of y remains negative 1. So it doesn't really matter. And of course, when x is minus 360, the value of y remains 0. So you can again see that it is this part that is reflected to this part along the y-axis. And this is now the graph of y is equals to the function of x moduled. You can see the positive part of x is reflected along the y-axis. This particular point, the negative part of y is reflected along the x-axis. And that is just like it in this particular example. All right?